Hello, PreCalc. This is an optional observation, but how about this? If you watch these and write them all down and graph them, I will give you 2 points extra credit towards your class work. So that will be some incentive. So write down the expression here, all the steps, and the final graphing, and I will give you extra credit. So how's that? What a deal. The reason I'm pressing you to do that is because there are 4 problems, very much like you'll see tomorrow on our test. So let's go ahead and practice them. I'll be going a little faster than you may be able to write, perhaps, so feel free to pause and catch up and start the video again. We wrote these down in class. Here's the first one, and notice there's a y squared term. It is not there's not an x squared term, so that means we have a parabola. The parabola has a standard form, and it looks like this. Y minus k quantity squared equals 4p x minus h. When y is squared, that's a horizontal. Now, if we had had the opposite, x squared minus, oops, not x squared, x minus h quantity squared equals 4p y minus k, then we would have had a vertical. So you can see that this one has the y squared term, not the x squared term. So we don't need this one, but you may need it tomorrow. So be aware that it could go either way. All right, the parabola is like that, and the first step then is to gather your x terms and we're going to, in this case, gather our y terms and put our x term and our constant on the other side. So we're going to, since there's so many negative signs, I'm in a pretty good mood. I want to get rid of the negatives. So I'm going to multiply everything by a -1 just so I can work with positive values. Notice then that I'm ready to complete the square on the left, but there's a 2 sitting there and it has to be a 1 before I can complete the square. So I'm going to factor out of 2 on the left. And when I do that, it leaves me y squared plus 2y, so the number in front of the y squared is an unwritten, usually unwritten 1. And now I can complete the square right there. What number will you add? Plus 1, and you'll adjust for it by adding 2 to the other side because the 1 you added is a 2. Alright, now what's the perfect square you've created by adding that 1? It is y plus 1 quantity squared equals x plus 3 now. And we're almost in standard form, except you'll notice there's no number allowed out here. So what can we do with the 2? What can we do? What can we do? What can we do with the 2? We can divide both sides by 2. And that will remove our problem from the left. And we're going to write it in a special form. We're going to put it out in front here. And that dividing by 2 creates a 1/2 in front of the expression. Those are equivalent, mathematically equal. So now all the secrets of this parabola have been revealed. What is the vertex? It's going to be the opposite of this. Where'd this negative sign come from? Put your hands down. I see it. All right. This was positive and this was positive. -3 minus 1 are the coordinates of the vertex. So start graphing it. -3 minus 1 is right there. So I know it's horizontal, so it's either going to open this way or it's going to open that way. And the way you tell is you look at P. This takes the position of 4p, so I'm going to indicate that 4p, running out of room here, 4p equals 1/2, and dividing both sides by 4, I get p is 1/8. I notice p is positive. When p is positive, it opens to the right. So I'm going to go ahead then and find one other point. I know it's going to open this way. And I'm going to do a point, so I went way back to the original, and I put in a 0 for y because that was quick to do, and that gave me x equals -1. So that gives me another point I can put on this parabola. 0 for x, -1, no, what was it? -1, 0, sorry. -1 for x, 0 for y. So right here, there's a mirrored point over there, and we have a quick sketch, fairly accurate as well. All right, the parabola's down. All right, so you'll have one of each of these. Because of time, I couldn't give you a lot, so you're going to have to work accurately because there's not that many problems, so that's always a pain, but I don't know what else to do. All right, here we have the second one, and we see there's an x squared term and a y squared term. So, and we see that the coefficients are not alike and their signs are not alike. So that's what happens when we have a hyperbola. The hyperbola has a standard form like this, and the reason I picked y as being positive is I saw y was positive. So there's another rendition of this where we could have had the x minus h quantity squared over a squared and the y squared, or y minus k quantity squared over the b squared equals 1. We could have had that, but that's not what happened here because I can see that the x squared term is negative and the y squared term is positive, so I went with this one. When that happens, when the y squared is positive, it is a vertical. So we have a vertical ellipse on our hands. So let's see if we can handle it. We're going to go back to this original, gather your x together, gather your y together, and take the constant to the other side. Where does that work? Right here. Let me pan in a little bit, or pan out. All right, so I gathered the y, gathered the x. Notice behind this negative sign, there has to be a negative sign. It's not so tricky with the 9x squared, but this term appears up here as negative, but down here it's positive because this negative affects the terms behind it. All right, so before we can complete the square, this has to be a 1, so I factor out a 25 there, and I factor out a 9 here. A 9, what am I doing? Craziness is what I'm doing. All right, that was there. There is no x squared term up here. There's an x squared term, there's no x term. So that 9x squared term should just sit by its little lonesome and be content about it. So I messed up. So let's get it all out of our systems tonight. So back here, 25y squared and a minus 100y. For some reason, I paired that also with the x squared. No. So I need an x squared term. There is none. So this one just sits by itself and the constant goes to the other side. Please forgive me. All right, now I'm going to pull out the 25 so I can complete the square and the 9, so to speak. And we have the 125 sitting here. Then, all right, I added a number here, and it's going to be a 4. And this one I did not have to do anything with. I realized that that 4 is really a 100, so I added 100 on the other side. Now I figure out what is the perfect square that I made. By adding the 4, it's y minus 2 quantity squared. Let's get the shadow off. And that 125 plus 100 became 225. All right. To be in standard form, this 25 and this has to be a 1. So I'm going to divide everything by it. And 25 over 225 and 9 over 225 reduce nicely to that. So we're ready for graphing. The center is going to be 0 for x and positive 2 for y. So I'm going to graph this 0, 2. And then I have to do a chart. And the chart allows me to look at the close cousin. Notice I dropped Hector and Kyle, so I'm just looking at the bare bones equation without the h and the k. And I zero out x to get y, and I zero out y to get x. And these are the values I got. So let's go up and finish. So from this point, I'm going to go up and down 3. And from this center, I'm going to go left and right 5. And I create a box, diagonals through the center and the vertices of corners of the box. And I already established this was a horizontal, so it's going to be fenced in by these asymptotes. It's going to touch this point. This little chart here also tells me which way it goes, because it helps us get the box, but it's not real. So that point is not going to be on the hyperbola, so it must open up and down vertically. All right, good to go.